Hello, class.
Hello.
How y'all doing?
Okay.
So we got just 5 people logged in. I guess everybody's on the roll. Guess we just get started. Go to share. Oh, 6 person coming in. Okay. All right. Hopefully we're gonna finish up our chapter 3 on modules. And what I'm gonna do, I'm gonna post the quiz reading chapter 3, and I'm gonna post an assignment quiz. What this quiz is, you're gonna be given variables that's gonna be declared to be of some data type. Like you got float value, int, number, one and two, num one, num two, char, C, and string, code, and name. And what I do is I give you some assignments where I might say, let's go here. So like this first one, value. Now whatever value is, it's saying it's equal to 3.673. And you have to determine whatever the data type of value is, can this value be stored in that variable, whether or not it's a valid statement. Uh, Let me go to one here. Go to here, name. Now, depending on what the data type of name is, can Caleb, CALEB, be stored into name? So you got to understand your rules for char values, char variables, and string variables. All right, and stuff like that. So on and on. Even if we have something from float going into int, we know we're not worrying about the value that's going to be stored. We just want to know if it's valid or not, because we know we can store what a int into a float, or either a float into an int. It's just going to truncate. Okay, but when you start dealing with string and char, it depends. Char, what? A single character. String, a series of characters. All right. Um, but that's going to be a quiz that I'll post. And like I say, you'll go through it and answer those questions. Also, like I say, that next assignment, uh, I'll go ahead on and post it. Well, then I'll also post the chapter 3 quiz on module. So that just will be a few questions out of the chapter that you're gonna have on a quiz. Uh, then this one, like I say, it's available now, but it's that assignment with dealing with modules. It'll be due on Monday of next. I think Monday of next week. Okay, and then I'll go ahead on and post the test also. Okay, so let's. Anybody with any questions? Anybody have any questions? Any type questions? All right. If there's no questions, let's get back to our notes. Uh, okay. In our notes, I'll move this over a little bit more. All right. So in our notes, we stopped on pretty much duplicate variables, where we said it told us that you cannot have two variables of the same name uh, uh, with the same name in the same module because of the compiler or the interpreter. But some programs allow duplicate names, but most do not. But then you can use multiple names depending on what the scope of the variable. When we talked about the scope, where's that variable is valid or can be used at. All right. So then we got to passing arguments to modules. Well, what is a module? We said that a module was a small, well, it can be small, but a section of code that that is separated from actually the main portion of the program that can be called on and executed, and then you return back to the main program. All right. So, and then we talked about some benefits. You can call it as many times as you want, so that you won't have to keep duplicating the same code in your program. All right. Um, so passing arguments to modules. Let's open up Visual Studio and kind of get insight on modules. Could just give you an insight of what we was talking about when we was talking about modules. And what I'll do, I'll remove all this here. All right. So okay, int main, and then this is your shell. So if I have a module here and I may call it, well, let's say header, I call heading, um, what I'll just say column headings. Okay, I'll say void call headings. All right, and I'll call it this. Now I have to actually define what that function is. So remember, we said this would be our what prototype. Okay, we define our function. Okay, so we'll have void. That's what we have at the top. The name of the function, call, if I could type. And then you don't put a semicolon here because you're going to define in your open and close bracket, curly braces, what is going to be happening in that function. So I could do something like see out, I'll do whatever, if I could type. And I'll say name, and then I can do something like what? So I'll do stop tab twice, and I might do address, and I'm just using tab just to space over, so you can see. And then I might do, something like phone. Now, so and then an inline at the end. So what happens is I have this function and I need to close it. I thought yeah, okay, I did. So I have this function defined. I have the prototype, the definition of the function, but in order for me, for it to execute, I need to call it from within my program. So I don't have nothing else going on in the program. I just have this function. So say I call this function to call it so that I can execute those statements. And I'll just do this. That's how you call it, the function name and the semicolon. Now, there's some other things you can do here depending on what you're returning, etc. But at this time, it's void. So if I execute this, we know that we're going to get what? Name, address, phone, printed out, and then it's going to end the program. So let's run the program. Let me maximize this real quick. Make it a little larger here. Oh no, what did I do? What did I do? What did I do? Let's see something. I'm going to copy this, Control A, C. Because I think what it did not open it in in the Visual Studio frame. So all right. So now we have it here where we could execute it. So now what I do is I'll go ahead on and debug it because I've already compiled this name. Now, when you look at it, look, you have name, address, phone number. Now, say you was doing a report and you were sorting, or maybe, you were sorting a report by, say, city or whatever field. But let's say city, and you had X number of people in one city that you printed out, that you print the name, address, phone. Then you might have another city and you have so many people, name, address, phone. Then you have another city. So rather than you having to write this particular statement for the heading multiple times, each time you had a new sort or a new group of information, all you had to do was wherever you had it in your program, you just do, and it's going to execute that statement. So it's going to execute this function this first time, and then it's going to return back, call it again, execute it again, and then in the program. So you can call that function as many times as you want. It's no limit. So watch what happens. See what happens? So now what? Without me having to rewrite code, I've executed that code twice rather than me having to write what? This cout statement multiple times. All right. So if I make a change to anything in this cout statement here, as many times as I called it, it'll be automatically changed. I don't have to try to find how many times I've written it in the program and go to each step, each statement and change it, change what I've changed. All right. So that's one of the benefits of using functions. Now, so that's just a little recap. So now let's get back to the notes. Now I say passing arguments to modules. And we kind of looked at this and some people had to go, but passing arguments by modules, to modules. What that means is if I have a program, all right, and let me take this out. I could have left it in there. All right. So what happens is I declare a variable. I'll say, okay, int length, okay, equals 5. All right. And I could give it a value, comma, width equals 8. All right. So I've declared some variables inside the what? The main function. Now, the scope of length and width is what? Inside the main function. Any other function in my program does not know what these variable names are, right? If I try to say cout length, if I could type, I should get an error. See, because the program does not know what length is because length is only available in this scope, all right? The scope of main, all right? So I would get an error. Now, remember what we talked about when we talk about global variables, because that would be local to the main. If I copy this or cut this, all right, and I pasted it at the very beginning of the program. Now what I've done, I've just made length and width global. The scope of those two variables now are known anywhere in my program. Okay. So now if I go in here and say length, cout length, the program will understand and know that what? Oh, length is global. I can use it because it's known throughout the program. Okay, but if I just simply take this and place it back within, cut it out and place it back within the main function, you see here, I've just made it local only to the main function. All right, so you got to understand the concept of global variables and local variables. And when you write code, a lot of times I'll tell you, make this variable global, make this variable local, because you can easily write a program with everything being global, but you can run into problems where you change values and not know when and where they're changed, which makes it harder to debug program. All right. So now passing of we're talking about passing a value to an argument to a module. All right. So an argument is any piece of data that is passed into a module when the module is called. So if I have a char value, I could pass it to the module. If I have a string value, I could pass it to the module. If I have an int or float value, I could pass it to the module from the one module, to the next module. Okay. A parameter is a variable that receives the arguments, okay, that is passed to the module. So when we go back here to our program, now we have length and width within the main function. We want to find some kind of way to send the number 5 or the value 5 and the value 8 to the call heading function. All right. So to do that, we need to pass those values. Now, you could pass a value or you could pass the value of a variable. All right. So I'll give you an example how we could pass a value. All right. So if I do something like I'll take this out and we'll add it back later. All right. So if I do something like, okay, I want to pass 8 and 5, I could do something like and I'm gonna have to change my information up top. Heading, and then I can do 5, comma 8. All right. Now, but over here, I have to tell it 5 is an int, 8 is an int. So I have to tell my program that I'm passing 2 integer values. All right. But at the same time, I also need, oh, that should be an S. So I also need to allow the call function to receive those values. So now I can create a variable to store these values in. So I could say int x, int y, right? Or whatever variable name I want. So what happens is now 5 will be passed in the x. X becomes the scope of call headings, and y becomes a variable in the scope of call headings. So now what I can do, I could do something like say int perimeter. I'll do something for perimeter. And perimeter is equal to x times 2 plus y times 2. All that's saying is x plus x and y plus y, to give you the outside length of a rectangle or square. All right. So we found the perimeter. So now I can do a see out and see out the perimeter. We know we have that in there. We can take it out now. And I'll just say perimeter. And I'll say all right. So now what happened is I don't have any variables here. I have some constant values. So I said I want to pass the number 5 to x and the number 8 to y. And once I pass them into these variables, then I declared a variable called perimeter. Now, perimeter is only known in what? The scope of perimeter is what? Heading. So I can't try to print perimeter in the main function. I can only print perimeter here. So now I find out that x times 2 plus y times 2, get that value, and then print out that value here and then return back to the main function. So watch, when I run the program, all right, so what? It's 5 times 5, I did 5 times 2 is 10, and 8 times 2 is 16. So 16 plus 10 is 26. Okay, so it took those values from the main, sent them to the call function, and then calculated the results and store them into the new variable in that call function and print it out the value, return back and exit. All right. So now that's how you can pass a value, but you also can pass a value by setting it equal to a variable, just like we had int let equals 5, and then width equals 8. So now what we've done, we have assigned values to variables. So now rather than we use let 5 and 8, I can use let and I can use width. All right, because what? Length is equal to what? 5. Width is equal to 8. So now what? The value of length is being passed into a variable called x, and the value of width is being passed to a variable called y, and it's going to give me the exact same result. Everybody see that picture. All right. And like you say, you may use variables here because what? You might ask a user to what? Input some values rather than have constant values. So when the user inputting values, the value can fluctuate, can be anything. But if I just put 5 and 8 here, every time I run my program, or even put the length is 5 and width is 8 and don't have a CN, then every time I run the program, I'm going to get the exact same answer. All right. So if I run this program, all right, it's going to give me the answer because it's going to pass 5 into x, or length is 5. 5 is being passed to x. Width is 8, so it's passing 8 to y. All right. Now, previously we talked about variables of the same with the same same name. Being that this scope and this scope is different, we can use the exact same names. So I could do something like this. All right. Now, so what I'm doing, I'm passing length, which is in the scope of main, the value of it, into length, which is in the scope of call heading, which is two different variables because they're in two different scopes. And then I'll put length here because what? That's my variable being declared within the scope. And then I'll put width. All right. Okay, here. So now you see how I've written a program. I have length and width in this scope, and then I have length and width in this scope, but they are two separate variables. They're not the same. All right. Now, you might say, well, Mr. Vesta, or anybody have any questions? Any questions? Anybody? Okay. Now, I'll show you something. In this program, what I'm going to do, not program, function. What I'm going to do, I'm going to see out in the main function, I'm going to output the length, okay, and then I'm going to output, that's one, output the width. All right, so now, you say, okay, Mr. Professor, why you did that? So what I'm going to do now is I'm going to take this same, well, I'm going to have to change the heading part. I'm going to copy this, and in here, I'm going to add something to length and width and print it out. So I'm going to paste here this, but this is the, all right. So now, but what I'm going to do, I'm going to say here, length is equal to length. Let's add two plus 2. So what I'm really doing, that's spelled wrong. Okay. What I'm really doing is saying, okay, I'm taking 5, passing it here. I'm calculating my perimeter, but then I'm going to take 5 and add 2 to it. So this should print 7 here. All right. Then I'm going to do the same with width. So 8 plus 2 going to give me 10. All right. But I'm going to calculate the correct perimeter. Then I'm going to add 2 to each one of them. And I'm going to output the length here. But then they're going to return back to the main function. And it's going to output the length again. So we're going to see exactly if it's going to give us the same value. So watch what happens. I got an error. Let's see. No. Where's my error? Oh, here. Oh, yeah, because I copied it, remember? So what I had to do the other one, that one I do the other one. So let me debug it again. And now, look what happens. All right. Yeah. So look, here we passed. Let's track the program. And let me minimize, let me move this. I want you to see what happens. All right. And here. So let's track the program. What happened is, let's start here. Okay. We length is 5, width is 8. Then we call the heading function, call heading function, passing 5 and 8 to call headings and passing the values 5 in the length and 5 in the width. Okay. We declared a variable called perimeter. Then we calculated the perimeter by multiplying length, which is 5 times 2, plus which is width, which is 8 times 2. So 5 times 2 is 10, plus 8 times 2 is 16. So 10 and 16, we outputted the perimeter, which is what? 26. So after that, after I printed the perimeter, I added 2 to length, okay? Then I added 2 to width. So what? 5 plus 2, the call heading function, that's the length. It's 7, all right? The width, we added 2. 8 plus 2 is 10. But then what happened? We went back, we got to the end of the function, so we returned back to the main function where we printing out the same exact thing, the length and the width. Oh, no. The length and the width. But the length and the width is of the scope of the main. So the length in main, the value is what? 5. The length, not the length, the width in the main is the value 8. So everybody see what happened. In here, the length was changed to a different value because we added to it. But then in here, the length stayed to whatever that value was here because the effects that it has here does not affect the length or the width in the scope. Anybody with any questions? Everybody kind of understanding how that scope works? Questions? Anybody? All right. Yeah, sure. So now, back to the program. So that's basically what they're saying here. What they did, this is a function called double number, all right? And it's passing the number 4, all right? But it's passing the number 4 into an integer called value. So what they did, they multiplied, they declared a variable called results to be int, and then they multiplied value times 2, and then they printed out results. Result is equal to value times 2, and then print out results. So if I would have put an 8 here, then that it would have passed 8 in the value, 8 times 2, which would be 16. So result would be 16. Everybody understand that? All right. That's the pseudocode. And this is another example kind of showing you what's happening. This is the main function where you're calling the function double number, but 4 is being passed to double number and is being stored into an integer variable called value. Same thing. So that's all it's showing you. Now, and later on it's going to show you can pass multiple values, which we did. we pass multiple in this program here, we passed what not x length and width. So you can pass either one variable, or you could or value, or you could pass multiple variables by simply separating them with a comma. But then you have to tell the data type, and each one have to be specified, separated by a comma. And then in your function definition, you have to declare each variable that's going to accept those values, and give the data type and the variable name separated by a comma. Okay, so those are some of the rules you got to follow when you writing when you're creating functions in your programs. All right. Um, so and basically this is the same program, but all it's doing, rather than it allowing you to input a value. So you see in something in the number, and then you're passing number to that call function, which is double number, and then you pass it, like say they enter 20, and 20 times 2 give you 40, and that's where results equal to 40, and it prints out results. All right. Okay. All right. So arguments and parameters, we kind of talked about them, but it's basically the same thing. When you pass an argument to a module, all right, most programming languages require that the argument, all right, and the receiving parameter variable be of the same data type, all right? If you try to pass an argument to argument of one type into a parameter variable of another type, it an error usually occurs. Okay, so sometimes it depends on the compiler, but I think in C++, that's not the issue, because C++ is a low-level language. And watch, I'm gonna do this. I'm gonna say, okay, I'll say float 8. You see what happened? So, because it knows that what? This is float, but if I'm gonna pass it to an int, it's gonna truncate whatever, and it's gonna still give me the same answer. You got me? So, but some compilers, it just letting you know that some compilers, all this has to match. All right. Because remember when we did the CN, it won't give you an error if you're trying to CN a float into an int. It's just gonna truncate it, and it could cause your reads to mess up. All right. So you gotta watch it. Being that C is a low-level language, some of those things does not apply, because it will go ahead on and say, okay, you're telling me you're sending me a float. You're telling me this is a float, but you're trying to put it in an int. I'm going to go ahead and accept it, but I'm going to just truncate the decimal place off and continue on with the program, because that may be something that you're trying to do. It just depends on the logic of the program. All right, what it is to be doing. All right, so look here. And this is what they're saying, but this is not true in C++. See, arguments and parameter variables must be of the same data type. So see how it's telling you they're trying to pass a real, or which is a float value, into an int, and what? They said, nope, that's an error. Now, what happens is they'll take this value and store it in the int C++, and it's going to truncate the 0.9. So only 55 will be stored. All right. So you gotta watch. You gotta watch what happens. So let's go back to this program and do that. Because like I said, I think it's a low-level language, and it will allow you to do that. So I'll say 8.8. All right. So when we run this, we know that where is it? So we take in a float, okay, int. In a float, well, let's make that. Yep, but this is an int. But we know in here is a float. So when we run this, let's debug it. It still should give us the exact same answer. You see what I'm saying? It promoted it. No. This is just what the value is in the main function. It is a float. But in the cal heading, we got the same answer here, because it passed 8 rather than 8.8. and then what? It doubled the 5, and then it doubled the not double though. It added 2 to 5 and added 2 to 8. You see what I'm saying? But when it went back to the main function where width was 8.8, we got the 5 and the 8.8. All right. So C++, being that is a low level language, you get by on those errors because it'll handle it in a certain way. But you, as a programmer, you need to know how it is handled because you could get output that's not correct. And if you got hundreds of lines of code and you got 5 or 6 of these, not say mistakes, but places where you putting a float into an int and you're truncating, you could lose a lot of data. All right. So all your numbers could be way off. All right. So the parameter variable scope, and like I say, what happens is once you create that function, all right, like we did here, even though the variable name is the same as in the main function, this length, the scope is within this function, all right? This length, the scope is within the main function, all right? So you gotta watch it, because I could have had a different name here, like I had before X and Y. But if I do that, then I'm gonna have to change this to X and Y because it wouldn't know what length and width is again. And then this to X, this to Y, this to X, this to Y. Okay. So whatever I declared it, because this is pretty much where you come somewhat declaring those variables that being receiving the values. So you have to know what they are and then use them inside of the scope. All right. And like I said, if you had global variables, they can be used anywhere in any function. All right. Now, passing multiple arguments, we just did that. We passed X and not X and Y. We passed length and width. So you just simply can use a comma and pass multiple arguments. All right. So look, in this one, they passed a integer value called num1 and an integer value called num2. We passed a integer value called length and an integer value called width. Same difference. So you can pass as many variables as you want to a function. All right. It does not matter. All right. And what happens is one of the rules is you have to list them in the order that you expect to receive them. Example, we have the first number, which is 12. It's going to be stored into num1. The second value is 45. It's going to be stored into num2. Now, it's important because depending on what kind of expression you have, 12 is going into num1 and 45 is going into num2. And if you have something like 0, like if 45 was 0 and you were dividing 12 by 0, then all of a sudden you would get an undefined value. So, and you say, well, no, I'm not dividing by 0. I'm doing whatever. Well, you may have your numbers, transposed in the wrong place or whatever. So it's important to know, however you have your numbers listed. If you got 5 values you passing, and then you passing them into 5 different arguments, they have to be listed in that order, from 1 to 5, in the order that you're passing them into. All right. So be mindful of that. All right. Now, so like I said, this was like the hierarchy chart, and we kind of looked at that. This would be a function. This would be a function. It would be called from the main function, and this is called from the main function. Which one is called first? You don't really know, but all you know is that what? This function is being called from the main, and this one is being called from the main. All right. All right, so that's checkpoint. Now, passing arguments by value and by reference. So we pass the argument by value. Value saying I'm gonna pass it by whatever value that I have in that function. So if you look here, let me close this out. This same program here, when we executed this program, when we printed the values from the main function, we got what? 5 and 8.8, correct? Well, I'm gonna change this back to int so that we can understand. I'm gonna change this back to int. All right. So now, In the main function, length is 5, width is 8. All right, we called the column headings, and then we passed the values, and what? We calculated perimeter, and then we printed perimeter, and then we added 2 to the length and to the width. We printed out that value, and then we went back, and then we actually looked at printed out the length and the width of the main. But if we, all right, if we were to pass the values by reference, and what that means is rather than passing the value of the variable, I'm passing the address of where the variable is stored. The key thing to remember about that is whatever is done to the variable in that call function is going to be done to the variable in the main function. Everybody got that? If I pass by reference, whatever is done to that variable in the called function will be done in anywhere that variable is being used or going to be used, because I'm passing it by the reference of the address where it's stored. Okay. Now you might say, well, how does that differ from just doing it this way, passing it by value? All right. So let's look at the output of this. Well, let me run it again because I changed it to make it look a little different. So if we run this program the way it is, all right. I'm gonna put a /t here. I want it all to look the same. All right, so let's debug it again and look at it. All right, so we have the value or the calculated value for perimeter. Then we printed out the value of the column, X and Y in the column headings function. And then we printed out the value of, not X and Y, length and width in the main function, which is 2 different values. But watch this though. This time I'm gonna pass by reference. Now you say, well, how you pass by reference? Basically, this is done the same way. Your call statement is the same, but rather in your prototype, you're gonna, rather than just use the data type, you're gonna tell it, oh, I want to pass use, and you're gonna use the ampersand saying I'm gonna pass the address. Okay, so now you're passing the address. So now what happens is, if I get this right, now you do you're passing this, all right, and it's gonna be stored into that address. And now, what happened here? No call. Yeah, okay. So now what happens if I execute this program, whatever is done in this parameters function will alter the values of the variables that's in this function. So that means what? When I print out length and width for the column headings function here and get what 7 and 10, when I return back to the main function and print out length and width, I still should get what? 7 and 10. So watch. When I run this program this time, what happened, class? Unable to start. Okay, let's see. All right, so here we go. So now look, my perimeter, 5 times 2 is 10, plus 8 times 2 is 16. But remember, at the end of the program of that function, I added 2 to 5 and got 7. I added 2 to 8 and got 10. Oh, we went back to the main function, and now we're printing out length and width, and it's what? It's the exact same thing as what? As the call function. Because what? I pass by reference, which means I'm passing the address, and when I check if I make a change to that variable add to it, multiply it, assign it a different value, it will change everywhere. All right, because I'm passing it by reference. Questions? Anybody with questions? Hello? Everybody understood what happened there? Right? Hello?
Yes, sir.
Okay, all right. So I just want you to understand. But what I had to do is basically the program was written the same way, but what? In my prototype, I'm saying I'm passing an int value, but I want to pass the address. I'm passing it by the reference. All right. I'm passing another variable by its address. Because I could tell it which ones I want to pass by reference. I don't have to pass all of them by reference. It's whatever one I decide to pass by reference. Then in the call function, I have to tell it that I'm going to receive an address. So in length, I'm creating a variable called length, but I want to put that that address in length. But then I'm going to use length to calculate whatever. And when I calculate everything with my length and width, I'm going to output length and width. But I'm passing my address in to create that variable location and allocate that space for it. Well, I'm not actually creating another variable because I'm using the address of what? Of the original variable. Okay. All right. All right. So that's how when you pass by reference, know that any variable you have, if you pass by reference, it's going to change when you make a change to it. Okay. If I add one to it, if I divide something by it, if it's passed by reference, it will be changed when you return back to that call function. All right. Or anywhere else in the program. So you have to keep track of where it's being changed so you know what's going on. Okay. Now, so that's passing by reference. All right. Okay. Let's see. That's still that's modules. Oh, this is pretty much the end of the chapter. Okay. Global variables, which we kind of talked about, and global constants. Okay. So if I had given you this program, I'll just say give you this to look at. And I say, create me a global variable called say amount and make it integer. And anything, well, just say create a global variable named amount of int. All you have to do is anywhere prior to the main, right? You do what? Int amount. So now what? The scope of amount is where? Throughout the program. Everybody got me? So that's a global variable, right? Even if I assign a value, okay, equals 28. Now what? Amount can be used anywhere in the program, but this amount can be changed because it's not what? Constant. So I can use that variable in my main function, multiply it, subtract from it, or whatever. Then I can use it, whatever value it's equal to when it leaves the main function, it's going to take that, and I call the call heading function. I could use that amount, I could use that variable called amount, and whatever it is at that point, it'll be used in the cal heading function. And if I add, subtract, or multiply whatever from it to it or whatever, it's going to change that value, and I return back to the main. It's going to have a value, and that's what it is. So that value will always be allowed to change or whatever anywhere in the program, and I can access it anywhere in the program. That's a global variable. All right, but if I add this simple command here, const int, all right, or I could say const float, const char, const string, whatever. When I do const in the front of it, and now I say what? It's in the global area, I can use amount anywhere in my program, but it can only and will only equal to 28. If I try to change it, it's going to give me an error. If I try to change it even to the same value, I'm going to give it an error, because when it sees the equal, if I say in the like say in this function, and I say amount equals, once it sees the equal sign, you're violating it. It's like, even if I'm trying to give it the same value, nope, you're trying to give it a value. You can't do it. It already has a value. It's constant. It cannot be changed. All right. So that's the difference between a global variable. A global variable can change anywhere, you make changes to it in the program. A global constant, a constant global variable can never be changed, but it can be used throughout the program. No matter what function you're in or whatever, can be used throughout the program. So that's the difference in those two type of variables. Okay. All right. So like I say, you got your global variable and then you got your global constant variables, right? And it says, in here, we just read what the definition of the book. I can move this over. Yeah. Definition of book: a global variable is a variable that is visible, which means can be used without any errors anywhere, we're visible to every module in your program. All right. So anywhere, if you got a global variable, you don't have to pass the value or anything. Just use it like you normally use any variable in the main function, because it's global. It's known everywhere in the program. And like I say, that can be kind of dangerous, because it'll make it hard to figure out where you change something if you're having an issue. All right. A global variable scope is what? The entire program, anywhere in the program. So all of the modules in the program can access a global variable. All right. So in most programming languages, you create a global variable by writing its declaration statement outside of any or all of the modules. And that's what we did when we created the amount the first time outside. Well, both times though, one was global, one was constant, outside of the main, which was outside of any other function. All right. So it made it what? Global. All right. So it made it global. So if looking here, this is why the main function is starting. All right. So, but if I do declare, when I do int number, I know that number here is global. So I can use number in this function. I can use number in my show whatever function without having to what? Pass the variable or the value. Okay. Without having to pass it. Yeah, let's say global constants. All right. Although you should try to avoid to use global variables, all right, it is permissible to use global constants in your program. Global constants is a named constant that is available to every module in the program. Because a global constant value cannot be changed during the program's execution, you do not have to worry about any of the potential hazards that are associated with the use of global variables. Because remember, global variables can change at any time, but a constant global can't. And remember, we talked about one use of a constant global would be like an interest rate, like a bank creating an application or whatever, and they have an interest rate. Rather than having to try to create a variable, pass it every time or whatever, if your interest rate is a particular interest rate, you can make that interest rate global. And then whenever you're using a module, you don't have to pass the interest rate. You know what you got it. You know what it is. It's constant. It's global. You can use it, multiply, do whatever you got to do to get the values, and you're done. All right. So I think that is the chapter. Yeah, that's the chapter. Anybody with any questions? Hello? Hello?
No, sir.
All right, so let's go back to to here. So what I'm gonna do, I'm gonna open up if I get my screen right. Yeah, okay. All right. So I'm gonna open up this. This is just the bonus quiz saying that you read the chapter and that's added to bonus. All right. It's just almost like a gimme. All right. Some people don't do it though, but yeah. All right. So I'll leave that open. Let's see. Oh, that's why I put a due date. Today is the 9th, so make this Monday. Okay. All right. And 11:59. Yeah. Okay. All right. So that's that quiz. All right. So now I'm gonna save that and publish it. Uh, the next quiz. Remember I told you the assignment quiz. So it's like dealing with the assignment statement. So I'm gonna open that quiz, and then the module, the chapter 3 quiz. So like I say, just look at the data types and see if they match or if it's valid or not. All right. Okay. What's this? All right. So that's that one. Okay. Think I'm and then we have this one, the modules. And that's just a few questions from the chapter. It shouldn't be. Oh, I got to take the password off. Take that off of there. Okay. Okay, save that and publish it. And then yeah, that assignment is still open. Oh, I gotta change the tips on this too. To 2. Okay. Save that. And go back to modules. Might need to change it over. And now this is the test. Like I say, hopefully I have my the proctorial set. I'll see. All right. And then if I do edit, okay, yep, two attempts. Let's see. Proctorial should come up. No. See? I don't know what the deal be with that proctorial. See, I don't know why. What's going on? Why is it blinking? What's happening? What's going on? Do y'all see this thing blinking?
Yes, sir. Looks.
I don't know what's happening.
Have to reload, maybe.
Okay, now it's done. Okay, I don't know what the deal was. I don't know what was going on. I guess it was trying to load it. So now no. I thought it said it was done. I don't know what's happening. All right, let me go back down. Test 3. And it should give me the proctorial. So it should give me that setting mark up here. Oh man, let's see something. Let's see. So that's, I don't know what's the deal. Let's see a situation. Did it take my information? Start execution. Okay. Oh, I don't want to be contacted. I want this stuff to start. No, I don't want you. Normally it should allow me to set it up. Um, well, like I said, I'll have to work on that and see. I don't know why it's blanking either. I don't know why, but I'll set up the test, and like I said, once I set it up, I'll inform you all that it's been set up and whatnot. All right. Anybody with any questions? What this? Any questions? If not, like I said, you got that assignment, that last assignment to do. I graded the first one. So somebody just, like I say, class programming, you got to calculate answers. We've done when we did string, string, you just manipulate string, we just printed out string based whatever. But in these assignments, you can't just give me the answer, whatever, like in double quotes. You gotta calculate the answer using variables and equations and whatnot. So make sure you understand that when you do the assignments. All right. Don't just give me a see out. The answer is this. All right, you gotta calculate it. Okay. All right. Any other questions? Anybody have any questions? Questions? All right. So if not, like I said, I'll see y'all on next class period. All right. And I think next class period we're gonna what we're gonna be dealing with. Let's see. Me in the screen here. And next class period, I don't think we get into the if logic yet. I think we're dealing with assignments and whatnot. Yeah, see, we did. Oh, we have the decision, the if logic. So it's gonna be if then if then else, and things of that nature. All right. So that's what we'll get started with on next class period. So you're gonna have programs that's gonna deal with input a value. If the value greater than whatever, do whatever. Or input of two values, add them up. If the value is greater than whatever, do whatever. Else, do whatever. So that's what we're going to get into on the next class period. All right. If else, if then else, and on and on. All right. So I'll see y'all on next class period. Do my work. Take your test. Like I said, I'll go on and try to reboot my computer and see what's going on and set it up. And I'll email you, let you know that the test is available. All right. So all right. If nothing else, I'll see y'all on next class period. Let's see what the chat. No one had one. All right. Have a good one. Okay.